In this lesson, we're going to create a 3D turning tool. So I have the file from this lesson open, Lathe 3D Tools, and I've saved it as an IP version. I'm going to go up to the Lathe Tool Manager and right click. You can see I have two types of tools I can create. I can create a tool or I can create a 3D tool. So the first level is the tool itself. You can see there's three levels. There's the tool, there's the holder, and there's the insert. So we'll give this a name and we'll call this right hand 35 degree 32 thousandths radius left side insert down. We are going to be an inch. So now I'll go down to the holder. And I'm just going to continue using this left side column here. We can also use back and next down below. So the name of this holder is going to be right hand 35 degree 3/8 IC 1-inch shank. So there's the holder. Now to get the holder I have a few options. I can go out to a step file. I can grab it from the MasterCAM file or the graphics window, or I can open it from the library. In this case I'm going to grab an STP file, which you have in your lesson. So it comes in with both the holder and the insert. So we're looking for the holder in this case. Now it highlights everything here. If there was more than one component to the holder, I would grab the other components at this point. So we'll say OK, and it brings it back. Now this is a general turning. When creating a 3D tool, we want to properly specify the tool type. So we'll select from the list the type of tool we are creating. Most of them are self-explanatory. The multifunction type refers to a tool that is used in many types of operations, like a mini turret. We have a variety of manufacturers we can choose here. We'll leave it at MasterCAM. This is a generic holder. If we had a code, we could put it in here. We can also add a manufacturer that's not in our list. The tool holder is for mounting the tool in a mill turn machine, so it never hurts to select this. Now our shank, you can see it wants to know the thickness and the width. So I'm going to grab the thickness up here, brings back an inch, and I'll grab the width. I might have done that backwards, but either way they're both 1 inch, so I win. So now the machine connection, we'll go out and grab it, and it kind of says, hey, put me here. So I'll do that. There's our plane connection, the machine connection specifically, the plane for the machine connection. So we've defined our holder at this point. We're going to go down to our insert. Now this brings me to an insert list. And I can either right click and create a new insert or a new cutting definition, or I can use the buttons down here. So I'll create a new insert, and I have the same options where I can choose from. I can choose from the library, the graphics window, or the step file. So we're going to grab from the step file, but I am going to name this. So that's 35 degree 3/8 IC 32 thousandths radius. I'll go back to the same model, and this time I'll grab the insert. So you see it brings the insert back, puts it on the holder, at least temporarily. This is a general turning. Again, we have some of the same information for the insert that we had before on the holder. Please note that we have a grade here. I've made up a couple grades, GC3254 and FG32TI. These are just made up grades just to show that we can put in there. Again, manufacturer code is possible. So I'm going to move down the left-hand column here, and doing next does the same thing. So now I'm into a cutting definition. And for a name, I'm going to put general. Next thing it wants to know is the corner radius. Now, let's look at a couple things here. First, you'll see that there's a red line around this. This is a required field, so I need to fill this in. The second thing is as you hover around on different items, you can see that MasterCAM gives you a tool tip. These tooltips are very helpful, so get in the habit of getting to know what the tooltip says until you're comfortable with the different settings and parameters that you're working on. So I'm going to go out and grab select corner radius here, and I'm going to grab the radius on the corner of the insert. I can grab the face if it's a nice smooth face, or I can grab the edge if I've got an edge. So I'm going to grab the edge here, and you can see it's 31,005 My tool offset number is 1. It's the first tool in. It will increment up as we make more. This is a right hand tool. So this is a nice graphic here that shows the difference between a right hand tool and a left hand tool. So for folks that know the difference, you just need to select the right one. For folks that don't know the difference, this is how you can tell the difference between a right hand tool and a left hand tool. So this is a right hand tool. I'll select that, and I am done with this slide over panel. Next I'll go down to mating panel. Now you can see that this insert came in place. So many times what we'll find is an insert will not be properly seated in its pocket. So in this case we don't need to do any mating. We'll do that in the future. I'll come back over to the next one in line here, and it's set up. So each one of these has a name at the top. Now it's looking for a cutting plane, and there's a little description of what the cutting plane is there. I'm going to go out and grab the top of the tool, and let's see what that does for me. Now you can see it brings back a couple things. It brings back a boundary on the outside edge of the tool, and it also brings back a boundary on the insert. Now the color of that is yellow. Again, we've talked about the orange and yellow designation for the insert. Orange being insert down, yellow being insert up. You'll also notice the insert up direction here, and our arrow is pointing in the right direction. If it was pointing in this direction, that would be incorrect. So we are good, but I just wanted to show what that looks like and what that does. If it was in the wrong direction, we could select the opposite here. The offset is to move the plane if it's not on the proper cutting plane. So a tool has to cut on the tip of the tool. And if the cutting plane is not on the tip of the tool, it's not going to cut correctly. So if we needed to move this plane for whatever reason, so for example, if I selected a named plane here rather than the top of the tool, and based on experience I know that the bottom plane here is probably going to come in pretty good, and it did. So the bottom plane came in with the insert up in the correct direction here. In this case I need to move this cutting plane up to the tip of the tool. So I'll do that with the offset function here. Wants a point. You can see the prompt up above wants a point. I'll come up to the tip of this. I'll select this tip, and now I'm back in the same place. So we did the same thing, selecting two different planes just to show the offset feature. So I'm actually going to put that back. We'll put that back to 0. We'll come back in here. We'll select the top of the tool. And it's just a little simpler like that. So next I have the boundary. Now the boundary very often comes in the same as the plane. And the boundary is like what it sounds. It's the outside edge of the cutter in the cutting plane. So in this case it came in good. We don't need to do anything special with it. If we did, we might have to adjust where the boundary is calculated from. So you can see I've got a plane on the top, a plane on the bottom, and it's selecting the boundary between these two planes. If I move this up, you can see how the plane, the boundary will be affected by what's in between those two planes. So we don't need to do this. I'm going to cancel that. And we can see that we have a good boundary. If we had a problem, we'd have a red outline around the box here. But I just wanted to show if you need to adjust for the boundary. So next up we have machine orientation. This is similar to the setup tool in the parametric library. So we do want this tool to be vertical. This is a OD turning tool versus horizontal, which would be a boring bar. It is on the top turret. We do not have an angle to this. We want this to be perpendicular to our axis of rotation. We are going to be on the left spindle. Now, we do want our tool to be in the insert down condition. So as this tool sits right here, if I use this on the left spindle, my insert is pointed away from the spindle, which can be used, but it's more for special situations. We can change the spindle rotation, which comes with a nice tooltip as a visual to clarify clockwise versus counterclockwise. I'm going to select this, and you can see that it turns my tool 180 degrees around the x-axis, and I am now in an insert down condition. My tool is pointed correctly towards the left spindle over here, and I have this oriented as I want it. So next, we need to tell it where the insert lies in space. We have a few options here. I can select the center of the radius. I can select 2 adjacent edges. I can select 3 points. I'm going to select 2 adjacent edges, 2 tangent edges to the radius. So I'm going to select these 2 here, and you can see it brings back the center of a 32 thousandths, actually a 31 thousandths and 5/10 radius. We are using the corner method here. There's a few options here. You can hover through them and see what they do. You can see that we are in quadrant 1. You can see that our plunge and cut direction are correct. Next, we need to do our tool clearance. So you can see side clearance from the tool tip there, and we can select from a line. So I'll come over and do that. And the height is for the collision checking. So you can do it from 2 arcs, an arc and a point, 2 points. I personally like the arc and a point. So I'm going to grab the arc down here and the point up there, and you can see it gives me a distance. So the end clearance is similar, only it's for the back side of the tool, the end of the tool. Again, you can hover here and it gives you a tip on what it's looking for. And again, it's looking for a clearance angle back here, so we'll use an angle and a point. The last thing we have is the parameters for the tool. And you can see we have a variety of parameters. We have the type of material it is, some default cutting parameters, toolpath parameters, coolant, and custom coolant. So I'm not going to change any of this. We have created our first 3D tool. So I'll green check out, and we have our new 3D tool here.